So, in Unit 1, we talked about solving inequalities with polynomial and rational functions. So, we have looked at how to do some inequalities before, and we're going to see a lot of those things popping back up here, just now trig is involved. The most simple way to solve an inequality is if you have a graph, okay? Because if you have a graph that we have provided here, this question says the graph of f is defined from negative 2 pi to positive 2 pi. What are all values of x for which f of x is less than or equal to 0? So what are we looking for? If f of x is less than or equal to 0, what does that look like on the graph? If the function is less than or equal to 0. What? Below the x-axis. Alright, so if a function is less than or equal to 0, that we could also say that that function is negative, and that is where the function is below the x-axis. So if I have a graph, all I got to do is look for where the function is below the x-axis, right there. And I can just highlight it. And then I need to give the domain where that happens. Domain is our x, those are our x coordinates. So for this first piece, it's from negative pi to 0. So I would say negative pi less than or equal to, yes, less than or equal to, because I have an or equal to sign here. Less than or equal to x, less than or equal to 0. And I could also have pi less than or equal to x less than or equal to 2 pi. Or they may give you this in interval notation, where it's a bracket negative pi 0 union pi to 2 pi. Like that. You don't have to have both types of the expressions there. Yes? It's more typical to see the union with the brackets. I think it's okay to put it with the inequality as well. You just don't see it written that way as often. Yeah. Okay. Now, they told us to restrict answers from negative 2 pi to 2 pi. So, in the grand scheme of things, there's more answers to this, right? But they told us only look between negative 2 pi and 2 pi. And pretty much all of our inequalities are going to restrict our domain, because trig functions repeat over and over and over and over again. If they don't restrict that domain, then you have to develop some way to put 2 pi k inside of intervals, and that just is a mess. So most of these are going to restrict our domain. Okay, so easiest way is if they give you a graph for this. If they give you one of these questions, calculator active, graph it, and see whenever the graph is either above or below the x-axis, whatever you're looking for, right? So if they give you that ability, then you can do those things. But as you can imagine, they're probably not going to give us the calculator or the graph all that often here. Another example is, what are all values of theta from 0 to 2 pi for which sine of theta is greater than or equal to square root of 2 over 2. Okay, so here, I can find, like last night or in class yesterday, we were finding sine of theta equals square root of 2 over 2, right? We found that a lot, right? And where does sine of theta equal positive square root of 2 over 2? Sine is your y-coordinate, so that happens right here and also right here. So at pi over 4 and 3 pi over 4. But we want to know where sine is greater than that, right? So it says here, since sine is the vertical displacement from the horizontal axis, we are looking for all possible angle measures where the y-coordinate's at least square root of 2 over 2, right? So my favorite way to do this is I like to, most of these are going to have 2 points where this happens, right? I like to connect them with a line. If you connect them with a line, those have the same y-coordinate, right? Sine is our y-coordinate. We want to know where sine is greater than these values. That's above. So that would be this section of the graph. And so when you're reporting this answer, always start at 0, right here, and then rotate around the circle. So not an answer right here at 0, not at pi over 6. Oh, right here at pi over 4, that's where we start, right? This has an or equal to sign, so I'm going to use a bracket and say pi over 4, 2. All of these are answers up here until you get here, and that's 3 pi over 4. This also could be written as pi over 4 less than or equal to theta less than or equal to 3 pi over 4. There. Okay, and then nothing else is an answer here, so as you go back around, you wouldn't have any answers. Okay, questions there? All right, so Mr. Passwater, on the worksheet you're going to do, he was really nice and put a picture of the unit circle. It's easier if it's already there, but if it's not, I usually draw myself a little picture of the unit circle and then do the same thing. Helps me picture what we're looking at there. So if we've got, like for example, 3, we've got 4 plus 2 cosine x and g of x equals 3. What are the values of the x in the xy plane from 0 to 2 pi for which f of x is less than g of x? So you really just need to take f of x and g of x and plug those into this statement right here. So we'll have 4 plus 2 cosine x is less than 3. And solving these works just like the equations, except there is one thing we have to watch out for. What do we do differently when we're solving inequalities? If we're dividing by a negative, we got to flip that inequality sign. So it actually doesn't come into play here, but we have to remember that, right? So we're just going to subtract the 4. 2 cosine x is less than negative 1. And then we divide the 2. So we got cosine of x is less than negative 1/2. And so Mr. Passwater did not give us the unit circle here, so I'm going to draw myself a little unit circle. Cosine is my x coordinate. I am thinking about where cosine is negative 1/2. That happens right here at this point. Negative 1/2 square root of 3 over 2. Right there. And right here at this point, negative 1/2 negative square root of 3 over 2. Right, and this is at 2 pi over 3 and 4 pi over 3. So connect them with a line. Didn't draw them quite right, but connect them with a line. And then we are looking for x values, cosine values, that are less than this. So like I connected these with that vertical line, right? I want any x values that are less than this. So when we're thinking about x values, cosine, we're thinking left or right for this. So any values less than negative 1/2 for that x coordinate are going to be found over here. So again, as you were giving your answers, you always want to start over here at 0, go around the circle, so 2 pi over 3. This time, I have just a less than sign, so I want to use a parentheses. And then all the answers are from 2 pi over 3 to 4 pi over 3, like that. Or this could be written as 2 pi over 3 less than x less than 4 pi over 3. Does not matter to me which way you give your answer, but you need to be able to recognize both. If that had been greater than, we would have chose the right side of that vertical line. Okay, let's look at example 4. I've got 3 cosine x is greater than square root of 3 plus cosine x. Now this one has 2 cosines, but unlike some of the homework from last night, neither one of them are squared, right? So this is not a quadratic here. We just need to get those cosines together. This is like 1 cosine x, so we're going to subtract 1 cosine x. What do I get when I do 3 cosine x minus 1 cosine x? 2 cosine x. There. And then I need to do one more thing. What should I do? Divide by 2. So I'm getting that cosine of x is greater than square root of 3 over 2. And so here I need to think about the unit circle. Okay, cosine x coordinate right here, I've got root 3 over 2 1/2. And right here, I've got root 3 over 2 negative 1/2. And so this is at pi over 6, and this is at 11 pi over 6. And I want to connect these two dots right here. And I'm looking for where cosine, the x-coordinate, is greater than. Right, so that is the right side of this line. That is from here to here. Now, you need to be careful on how you give your answers here. We might want to say pi over 6 to 11 pi over 6. But pi over 6 over to 11 pi over 6 would be wrong here, because that would be all the values from here on the unit circle all the way around here, right? That would give us the opposite of what we want. That would give us whenever cosine is less than square root of 3 over 2. So when you're giving your answers, always start at 0. Now 0 is an answer to this, right? So I got 0 up to, go counterclockwise, pi over 6. I used a bracket with 0 because it is solidly inside of the answers. But I have a greater than sign that doesn't have an or equal to with it. So I have to use a parentheses with the pi over 6. Then, none of these are answers from pi over 6 all the way around to 11 pi over 6. But at 11 pi over 6 to 2 pi. Though I'm back to the answer section. Yes. So if you have a less than sign or a greater than sign, you're mostly going to use parentheses, right? So notice up here I just use parentheses, straight parentheses, right? On the things that are the end points here, you want to use parentheses. The reason I did not use a parentheses at 0 or 2 pi is because 0 is an answer to this. It's like in the answers, right? If we wanted to, I guess I could probably draw it like, these are sort of like open circles right here. They don't include those values. But if I were giving any of the values in here, I would use a bracket, which I didn't need to do on that problem because I was just going from 2 pi over 3 to 4 pi over 3. But on this problem, like you got an open circle right here and an open circle right here. Those are not included. But 0 is in the middle of the answer, so we use a bracket with that one there. If you have an or equal to sign, like if it's h of x is greater than or equal to k of x, you just use brackets for everything for that. So it's really only like whenever you have to split an answer section, whenever it includes like 0 there, that you end up having to think about it much. Okay, we're going to take a break for a second. Notes. Those aren't the notes. All right, so on this worksheet here for, let me zoom in some here. For number 1, you should get pi over 3 to 2 pi over 3. You can give it, he gives inequality notation. You want brackets with both of them if you use the interval notation. And that's because it's an or equal to sign. For number 2, you want from pi over 3 to 5 pi over 3. That one's going to have parentheses if you used interval notation because you have a less than sign. And then for 3, you're going to get 0 to 5 pi over 4 and 7 pi over 4 to 2. Although it's like one big continuous, piece right here, you always have to start at 0 when you're giving that answer. Because if I go from 7 pi over 4 to 5 pi over 4, that's actually going like backwards, right? And our intervals can't go that way. So you always have to start right here at 0 whenever you're giving your answer. So you're going to start at 0. You say, oh, all of this is my answer up to here. So that is the, if you use brackets, it's going to be 0 to 5 pi over 4. And then none of this is my answer, but I picked back up here. And here I've got part of my answer from 7 pi over 4 to 2 pi. There. Because you have to keep in mind, these are like number values, right? So like 7 pi over 4 is 7 times pi divided by 4, which is going to give you like 5.4977. So it's actually a number, and you have to start at 0 and go in that direction there. Okay, questions there? Some of you are getting to 4 or 5. The keys posted. You can look at that tonight. I'm not going to spend time because not everybody's gotten there yet. And I want us to have enough time to get these last 2 super fun problems done. So whenever we learned inequalities, we had to do sign charts. And a lot of us have gotten pretty decent at a sign chart. And some of us said, that is hard. I'm not going to do it. And then it just keeps popping back up, doesn't it? Like we've been doing sign charts here and sign charts there, and it just keeps coming back up. These are going to be sign chart problems, okay? In my opinion, these are probably the hardest of the sign chart problems because the trig makes it more complicated. I'm just going to go through this first one. He gives you the steps there. You definitely can read through those if you want, but let's just go through it together. We need to find all of the places where 2 sine squared theta plus sine theta is less than 0. So if your trig stuff looks like a quadratic, you've got a sine squared and a regular sine, or a cosine squared and a regular cosine, you are probably going to have to make a sign chart on these. You're definitely going to have to factor. Now tomorrow, you're not going to see inequalities on the quiz. You'll see a problem like this, but it'll have an equal sign. And with the equal sign, they're much easier to do because you just need to find those 2 places where that equals 0. So I'm going to treat it like it's an equal sign first because I need to know the places where this function equals 0. So I need to factor out a sign. I will have sine of theta times 2 sine theta plus 1 is less than 0. Okay, so you're just taking a sign away from each of these. That second term only has a sign, but there's a 1 in front of there, so it has to stay as a placeholder. Okay, so then I need to find the places where this equals 0. Like if we were doing this with an easier problem, we would just set each equal to 0. So that's what I do here. I have sine of theta equals 0 and 2 sine theta plus 1 equals 0. And the first one is ready for me to start looking at the unit circle. But the second one, I need to subtract 1 from both sides. 2 sine theta equals negative 1. And I need to divide by 2. So sine of theta equals negative 1/2. And I would highly suggest drawing yourself a unit circle over here when doing these problems, because it's going to come in handy when we're doing our chart. So, I need to know where sine is 0. Sine is my y coordinates. Sine is 0 right here. Coordinates right here are 1, 0. And the coordinates right here are negative 1, 0. That is at 0, pi. And actually, notice right here on our restrictions, most of them did not have this, but I've got a or equal to sign right there with my 2 pi. So I want to include 2 pi as well, like 0 and 2 pi are both going to be included here. So I've got theta equals 0, pi, and 2 pi from that answer. And then I also want to think about where sine is negative 1/2. Sine is your y coordinate, so that's right here. And right, oh no, not right there. Back up. Right here. And right here. Right here we've got negative root 3 over 2 negative 1/2. And right here we've got positive root 3 over 2 negative 1/2. Okay, and this is at 7 pi over 6, and this is at 11 pi over 6. So here I'm getting theta equals 7 pi over 6 and 11 pi over 6. Now, like on the quiz tomorrow, these would be your answers, right? Like you would have 0 pi, 2 pi, 7 pi over 6, 11 pi over 6. Those would be your answers. Maybe not 2 pi because a lot of times they don't put the or equal to sign with the 2 pi for that, but you would be done if this were what you're going to do tomorrow. But the inequality makes it significantly more tricky here because while I might know like whenever this function equals 0, I need to know when this function is less than 0, when I get a negative value. So for that, I need to make a sign chart. So on that sign chart, all of these zeros go on the bottom. Sometimes it is hard to know what order to put them in if you just look at 0 pi, 2 pi, 7 pi over 6, and 11 pi over 6. Like, which one's bigger, 7 pi over 6 or pi? Sometimes you may have trouble with this. So, go around the unit circle. That's why I would really encourage you to draw something. Start at 0 right here. Go around the unit circle. That's the order they go in. So, 0, and then you go to pi. Then you have 7 pi over 6. Then you'll have 11 pi over 6, and then back to 2 pi. So the zeros go on the bottom of the chart, and then the factors, sine of theta and 2 sine theta plus 1, go on the side. So sine of theta and 2 sine theta plus 1. Make us a little chart here. Our answers here. So to me it is so helpful to think about the unit circle for this. Okay, so sine is your y coordinate, right? So if you're looking at the unit circle, this sine right here is your y coordinate. So if I start at 0 and I look between 0 and pi, so on this unit circle, y coordinates, are they positive or are they negative? They're positive. They're above the x-axis. If you're looking at the fully filled in unit circle, all of those have, all your y coordinates are positive from 0 to pi. All right. How about from pi to, actually, let's just think about, if we're thinking about sine, what about from pi all the way back over to 2 pi? All of those are negative, right? They're on the bottom half of the circle. All your y coordinates are negative here. Because since it's just sine, we can just straight think about the y coordinate, right? And so I'll get negative on all of these sections right here, because those are between pi and 2 pi. Okay, now, not quite as easy on the next section, okay? So I can still think about sine is my y coordinate, right? So what I'm going to do is I'm going to pick a point. So between 0 and pi, here's 0, here's pi. I'm going to pick any point between here. It doesn't matter which one you pick, as long as it's between 0 and pi. I like to pick this one right here because the numbers are easy. So this is the point 0, 1. So if I test this, right, 2 sine theta plus 1 is 2 times the y coordinate plus 1. So for this point, the y coordinate is 1. It would be 2 times 1 plus 1. That will give me 3. Is that a positive or a negative value? Positive value. We're good there. Now, are there any unit circle values between pi and 7 pi over 6? They're not. That doesn't mean there's no values, but they're just not ones we have memorized on the unit circle. That makes this next piece hard to think about, or harder to think about. I'm skipping it because of that. Let's go to the next part. 7 pi over 6 to 11 pi over 6. I can pick any point that I want in between 7 pi over 6 and 11 pi over 6, but I like to pick this one right here because the coordinates are easy. 0, negative 1. Right? And so my formula is 2 sine theta plus 1, but sine's just the y coordinate, right? So I'm going to take this y coordinate. I'm going to do 2 times sine theta, which is that y coordinate, negative 1, plus 1. That gives me negative 2 plus 1, which is negative 1. Negative right there. Okay, and then I'm running into the same problem right here for 11 pi over 6 to 2 pi. I don't have any unit circle values in between. So what I'm going to have to do, here, let's go back to between pi and 7 pi over 6. I'm just going to have to, pretend I'm picking a point right here, right? I don't know what the y coordinate of that point is, but I can tell what it is between, okay? So at this point, who knows about the x? I know it's a negative value. I really don't care about it. I only care about the y. What values does this y coordinate here fall between? We're between here, which has a y coordinate of, what do you think, David? 0 and negative 1/2, right? Because here we have a y coordinate of 0, and here we have a y coordinate of negative 1/2, and this point's between those two, so I need to pick a number between 0 and negative 1/2. Give me a number between 0 and negative 1/2. Okay, that's what I would pick too. Negative 1/4, but something like negative 1/10 or negative 0.2, that would work. You know, anything here. So I don't know an exact value, but I can do 2 times that y coordinate, which is negative 1/4, plus 1. Right, I'm plugging it in right here, plugging that y coordinate in. And so 2 times negative 1/4 plus 1, that is 2 times negative 1/4 is negative 1/2 plus 1, and that'll give me a positive 1/2. So positive right there. And you don't even really care. You don't need the exact value. You just need to know whether or not you get a positive or a negative. There. So we're going to do something similar over here. Because between 11 pi over 6 and 2 pi, no unit circle values for us to use. So I've got to think. I don't know what the y coordinate is, but I know what it's between. It's still between 0 and negative 1/2, right? So I could still call this negative 1/4 if I want, or negative 1/10, or negative 0.2. So it ends up the same as the other side. 2 times negative 1/4 plus 1 would give us, again, a 1/2 positive value here. The sign chart's I'm not saying any of it's just super easy, but the sign chart's the hardest here because you really have to do some intense thinking on that sign chart to make sure you get all of your positive and negatives correctly. But if you can get this part of your sign chart right, then it's the same as the other problems we've done from here. You just look down here, positive times positive gives me a positive, negative times positive gives me a negative, negative times negative gives me a positive, negative times positive gives me a negative. Which ones are my answers, the positives or the negatives? Negatives, because I had a less than 0, so negatives are my answer. It's a less than sign, not a less than or equal to, so just use parentheses with everything. You'll have pi to 7 pi over 6 union 11 pi over 6 to 2 pi. We did these in first period, and somebody asked, is there not a quicker way to do this? And unless they let you use a calculator, no, not really. Not that I'm aware of. If I find an easier way, I'll show you, but this is all I've got right here. With a calculator, you could do it quicker, but these are probably not going to be calculator active. Here, so that's the process, right? It's the same as the process was when we had things like x squared plus 2x minus 4 is less than 0, right? Factor, solve, make a sign chart, test your points. It's just harder to test those points here. So let's do one more here. So we've got a couple of these that we've done. This time everything's already on one side, right? We've got 2 cosine squared theta plus cosine theta minus 1. We need to factor. Now, this is not 2x squared plus x minus 1 is greater than or equal to 0, but it acts like it, okay, as far as our factoring goes. So, a lot of you are X method followers. So, if you are, remember with X method, if you have a number in front of x squared, you've got to multiply the 2 times the negative 1, and you're trying to multiply to get negative 2. And then you are trying to add to get the middle number, which is a positive 1. Okay. What numbers can we multiply to get negative 2, but add to get positive 1? 2 and negative 1. But it's not x minus 2, or x plus 2, x minus 1. What's the other step you have to remember if you're using X method? You've got to divide back by that coefficient. So you got to divide by 2 on both sides. Now on this side, that reduces and is just 1. On the right side, no reducing there, right? So remember, now you can keep that as 1 over 1 if you want. X's, or go with the bottom number. right? So this is going to be x minus 1, and then, I'm sorry, x plus 1, and then 2x minus 1. You can also just guess and check this. That's really how I do it, but I know a lot of you use the x method there, so went through that. Now, all of your x's just turn to cosines, right? So this factor is like this, cosine of theta plus 1 times 2 cosine of theta minus 1. So if you can factor the quadratic, you can factor the trig equation. You just think of those trig values like x's. Okay, questions? All right, and you will see some on your quiz tomorrow that don't have inequality signs, but you do have to factor them like this. Okay, so then we're setting each one of these equal to 0. Cosine of theta plus 1 equals 0. 2 cosine theta minus 1 equals 0. Over here, we got to subtract that 1. Cosine of theta equals negative 1. Over here, we got to add the 1. 2 cosine theta equals 1. Divide by 2. Cosine theta equals 1/2. And then I'm going to draw myself a unit circle over here. And so I got to think about where cosine is negative 1. Cosine's your x coordinate. Cosine is negative 1. Nope, not right there. Right here. Let me erase that dot that I put there. I might confuse this. Right here. This is negative 1, 0. That happens at pi. So we got theta equals pi. And then I got to think of where that x coordinate is 1/2. That happens right here. There's 1/2 root 3 over 2. And also right here, this is 1/2 negative root 3 over 2. So that is at pi over 3 and 5 pi over 3. So theta is pi over 3 and 5 pi over 3. On tomorrow's quiz, you might get a problem like this, except for it will have an equal sign, and your answers will be pi over 3 and 5 pi over 3. Those will be your answers. But having the inequality really kicks us up the notch. It makes it pretty significantly more difficult by putting that inequality there. So we've got to do a sign chart here. Even though they weren't answers this time, still put 0 and 2 pi on the edges because they're telling us to restrict our domain to 0 to 2 pi, so we want to include those. And then go around your unit circle. Right here, 0, 0, pi over 3, and then pi, and then 5 pi over 3, and then back to 2 pi. And then draw my little lines here. I need, from my left side of my chart, my factors need to go there. So cosine of theta plus 1 and 2 cosine of theta minus 1. And then leave yourself room for your answers there at the end. Okay, now, unlike the last problem, we're dealing with cosine. Is cosine your x or your y coordinate? It is your x. So this is like your x coordinate. This is like your x coordinate. We don't have just straight cosine or straight sine, So we don't have anywhere we can just think, oh, is that above or below the x-axis? But what we're going to do is we're going to pick us some points on that unit circle. So between 0 and pi, you can pick from any of the points here. Okay? There are two that are actually on the unit circle, right? I could do pi over 6 or pi over 4, where I actually know the values. I don't have to make something up. So I'm going to say maybe pi over 4. The coordinates here are square root of 2 over 2 and square root of 2 over 2. So for this top line, I need to do x coordinate, which is here, right, plus 1. Square root of 2 over 2 plus 1. I don't know the exact value of square root of 2 over 2, but a positive plus a positive, what am I going to get? Positive number. Positive here. Now, unlike the easier, like, polynomials, I like to go ahead and check 2 cosine theta minus 1 here as well. So if I do 2 times the square root of 2 over 2 plus 1 here, here I've got 2 times square root of 2 over 2. These 2's right here can cancel. So this is really the square root of 2 plus 1. And that's a positive plus a positive. I'm going to get a positive right there. Oh, I'm sorry. I'm messing up right there, aren't I? It should be minus 1. We need to think about it a little harder than that. It should be minus 1. Square root of 2 minus 1. Positive or negative? Still positive, because square root of 2 is bigger than 1, right? Square root of 1 is 1, right? So square root of 2 must be bigger than the square root of 1. Square root of 2 is between 1 and 2 somewhere, because square root of 4 would be 2 for that. So still get a positive number right there. Okay, checking that point? All right, now we need to keep going. Let's go around the unit circle here. From pi over 3 to pi, I could pick any point in between pi over 3 and pi. I like to use this point right here. Now, you could use 2 pi over 3. You could use 3 pi over 4. You could use 5 pi over 6. But I like this one because the numbers are easier, right? So this is the point 0, 1. And I care about the x coordinate because I'm looking at cosine, right? So if I try plugging that in for this top line, I would do x coordinate, which is 0 plus 1. It's going to give me a positive or a negative. 0 plus 1, positive, right? Then I would have to do 2 times 0. Minus 1. I keep messing that one up. Okay, that's going to be negative 1. I get a negative right here. Again, didn't have to use the point 0, 1, but it's easier to use 0, 1 because the numbers are very easy to do even in your head. Okay, next, let me pick a different color. I've got to go from pi to 5 pi over 3. That is from here over to here. Again, don't have to pick this point right here, but it's going to be the easiest point to pick because that's 0, negative 1. And I only care about the x coordinate, right? Is this going to be any different than the last one that I just did? My x coordinate is still 0, right? So when I plug into the top, I have x coordinate plus 1. 0 plus 1 is still 1. That's positive. And when I plug into the bottom, I get 2 times 0 minus 1. Still negative right there. Okay, we are almost there. Between 5 pi over 3 and 2 pi, I've got 2 unit circle values there, right? I could use 7 pi over 4, or I could use 11 pi over 6. Doesn't matter which one you want to use. Just to show you, like, it doesn't matter. Let's use 11 pi over 6. I will get square root of 3 over 2 negative 1/2 at that point. I realize everything's really running together here. All right, that's my test point. So for the cosine of theta plus 1, that's going to be square root of 3 over 2 plus 1, x-coordinate plus 1. That's positive plus positive. That gives me a positive. Now, it feels a little wrong if that whole top line is positive, but it should make sense. What's the very lowest cosine could ever be? Negative 1. So negative 1 plus 1 would give us 0, right? But any other value is going to give you a positive number. So you're going to get positives everywhere there. Then I would have 2 times square root of 3 over 2 minus 1. And so 2's cancel. I'm getting square root of 3 minus 1. Is that going to be positive or negative? Positive. Square root of 3 is bigger than 1. So that's going to give you a positive value. So it takes a lot of deep thinking to get all of that filled in. But once you have, then you just do like we do any other sign chart. I'll get positive, negative, negative, positive here. Which ones are going to be our answers? The positives or the negatives? Positives because we have, oh wait. I wrote that down wrong. That's a 0 right there. That shouldn't have been a 1. Greater than or equal to 0. So I choose the positives. So my answers are going to be from 0 to pi over 3 and 5 pi over 3 to 2 pi. Okay, questions? All right, you've got like 7 minutes left, so let's try to get maybe one more question done from that worksheet that you've got. 6 through 10 are chart problems, okay? 6 and 7 are already factored for you, so you don't have to factor them. You're going to set them equal to each other. There's not a ton of room on that worksheet. If you write bigger, you might want to show your work on page